Animal bone doesn't become a chess piece by carving a shape and calling it luxury. It becomes a precision part only after the bone is cleaned, stabilized, cut into defect-free blanks, machined to exact Staunton proportions, weighted to strict balance targets, then finished so it won't crack, yellow unevenly, or chip at high-impact points. It's like knight ears and bishop miters. Most bone chess sets on the market are made from legally sourced bovine bone, water buffalo bone, or camel bone byproducts from the food chain. Not from banned ivory. Real ivory is heavily restricted under CITES and national laws. And any workshop that claims ivory without airtight documentation is a legal and ethical red flag, which is why serious makers emphasize bone, resin, and certified materials. The process starts with raw bones arriving as a biological material loaded with fat, marrow, protein residues, and moisture. Bone is a composite of mineral, mostly hydroxyapatite plus collagen. And that combination behaves like a hard engineering plastic with a built-in contamination problem. If you machine it straight out of the animal, tools clog with fat, the surface stains, and the piece will keep shrinking and warping as moisture leaves. So the first industrial step is separation and selection. Makers want dense cortical bone, not spongy cancellous bone, because cortical bone is stronger, machines cleaner, and takes polish like an ivory substitute. Long bones like femurs and tibias provide the thick walls needed for large blanks, especially for kings and queens that need wide bases for stability. Next comes cleaning and degreasing. And this is where the expensive part starts, because yield loss is baked in. Bones are cut open and marrow is removed. Then the material goes through hot water cooking or controlled boiling to loosen tissue without burning it. Heat alone doesn't remove fats completely, so many workshops use alkaline baths, surfactants, or solvent-based degreasing systems to extract oils from the pores. If degreasing is incomplete, the finished piece develops translucent oily spots and a sour odor over time. No amount of polishing will hide that. After degreasing, the bone is whitened and disinfected. Industrial whitening is typically done with hydrogen peroxide rather than chlorine bleach, because peroxide oxidizes stains with less damage to the structure and less long-term yellowing. Concentration, temperature, time are controlled carefully because over-whitening can weaken the surface and make it chalky. While under-whitening leaves, it's inconsistent color that becomes obvious when all 32 pieces are lined up. Drying is not leave it in the sun. Bone must dry slowly and evenly to prevent stress cracks. So it's conditioned like wood. Controlled rooms manage temperature and humidity, so moisture leaves gradually. This conditioning can take days to weeks depending on thickness. That's one reason bone sets cost more than resin sets. Time is part of the manufacturing line. High-end makers may add stabilization. Bone has microporosity, and stabilization fills those pores with resin under vacuum or pressure, similar to stabilizing wood for knife handles. Vacuum impregnation reduces future moisture uptake, improves polish, and lowers the risk of micro-cracking at sharp details. It also makes machining more predictable, which matters when the goal is that every pawn feels identical in the hand. Only after all that does the factory turn bone into blanks. A saw cuts the cleaned bone into blocks or cylinders, and this is where defects are hunted aggressively. Bone can hide micro cracks, voids, and density variations. And each one becomes a catastrophic defect once you've carved a knight and a crack runs through the jaw. Workshops inspect blanks under strong light and sometimes diapenetrant style methods to reveal fractures, then reject a significant percentage before machining even starts. Machining begins on lathes for most pieces. Kings, queens, rooks, bishops, and pawns are rotationally symmetric, so a lathe can produce perfect profiles quickly if the material is consistent. The blank is chucked, then turned with sharp carbide tools at controlled speeds because bone burns and smells if you push too hard. And burning causes brown streaks that ruin the premium white look. Tool wear is faster than on wood, so tooling costs and downtime are real contributors to final price. Dimensional control is not optional, because championship-style Staunton sets are judged by proportions. King height, base diameter, and the relationship between pieces must look correct and feel stable during fast play. A professional set typically targets a king around 3.75 inches with a base proportion that matches standard board squares, and even small deviations become visible when pieces are clustered. Then comes the signature step that separates ordinary sets from expensive ones, the knights. Knights are rarely made entirely on the lathe because they're sculptural, not rotational. In bone sets, the knight is often hand-carved from a block using rotary tools, chisels, and fine files. Bone is unforgiving here. It chips at thin edges. It can split along hidden stress lines. And it punishes mistakes because you can't steam out damage like wood. The carver must keep both knights symmetrical in height, main depth, and facial expression. Because mismatched knights are the easiest flaw for buyers to spot. After primary shaping, each piece is drilled for weighting. Weighting is a mechanical performance feature, not a gimmick. A properly weighted chess piece has a low center of gravity, resists tipping during blitz play, and feels serious in the hand. The factory drills a cavity in the base, then inserts metal weights, commonly steel, sometimes brass, and in ultra-premium sets, tungsten for maximum mass and minimum volume. The weight is fixed with adhesive, then sealed with a plug so it can't rattle or shift. Balance is tested, not guessed. Makers check tip angle, base flatness, and mass consistency across identical pieces. In a high-end set, pawns shouldn't feel randomly light or heavy, because that inconsistency breaks the tactile rhythm players rely on. This balancing and matching time is invisible labor that drives cost. Now the surface finishing begins. And finishing is where bone shows every mistake. Pieces are sanded through multiple grits to remove tool marks, without rounding sharp details like rook crenellations or bishop cuts. Fine dust extraction is essential because bone dust is a respiratory hazard, and professional workshops run vacuum systems and filtration to protect workers and prevent dust. Contamination in polishing stages. Coloring is another complexity. Classic bone sets are white and black, but the black is rarely natural bone color. Many makers dye one army using deep black dyes or ebonizing processes so color penetrates beneath the surface. Dye control matters because uneven dye creates blotches, and poor penetration reveals white scratches during use. Dyes are fixed and sealed so the black side doesn't bleed onto boards or hands. Polishing creates the final luxury signal. Bone can take a high gloss, but achieving it requires compound buffing and controlled pressure, because overheating can soften surface resin, smear dye, or create microcracks. Premium sets often finish with protective waxes or sealants that reduce moisture, exchange, and fingerprints without creating a plastic-looking shine. The base is finished last because it's functional. A felt or leather pad is cut to diameter and applied with adhesive, creating smooth glide and protecting the board. Felt thickness and adhesion matter more than people think. Poor felt delaminates, wrinkles, and makes pieces rock slightly, which players feel instantly. High-end sets often use dense billiard-style felt or real leather, lined perfectly so no edge lifts. Quality control is where championship-level cost becomes obvious. Each piece is checked for symmetry, surface defects, cracks, dye uniformity, and base flatness. Sets are also matched visually because bone has natural grain and tone variation. And expensive sets are curated, so the whites match each other and the blacks match each other. This matching reduces usable yield, which pushes cost up. Now add the manufacturing realities that make bone expensive compared to wood or plastic. Bone supply is variable, so consistent, dense blanks are limited. Defect rejection is high, especially for large pieces. Processing takes time degreasing. Whitening, drying, stabilizing in time, ties up space and labor. Tooling wears faster, hand carving is slow. Finishing must be meticulous, because bright surfaces show every flaw. Finally, the premium price reflects risk and compliance. Legal sourcing documentation, export rules for animal byproducts, and hygiene controls add overhead. Reputable makers also avoid any association with illegal ivory, and that means tighter traceability and clearer material declarations, especially for international shipping where customs scrutiny is high. That's the real reason expensive bone chess sets exist, not because the shape is complicated, but because the factory is converting a biological composite into a matched, weighted, dimensionally consistent precision set where every defect is visible and every shortcut shows up years later as cracking, yellowing, odor, or imbalance. When the process is done correctly, the pieces feel dense, stable, and refined. And that championship impression is manufactured one controlled step at a time.